So dear students, today our topic is UV visible spectrophotometer. I've already taught you this. Now here's a video explanation. So what I showed you from the diagram here, this is the source of radiation, okay? And for UV visible, the source of radiation is usually halogen discharge lamp for UV radiations and tungsten halogen lamps for visible radiations. So this source of radiations, it emits radiations in all the directions, right? Now what we need to do is we need to set all these radiations in the same direction, or we need parallel radiations. For that what we need is, we call it a collimating system. Collimating means to make radiations parallel. Now see what happens. This radiation, it goes like this, and this lens, it converges these radiations, okay? It will converge these radiations like this. Okay, so all the radiations now are in a parallel direction. Then the next thing is, you call it a dispersing element, okay? Because here you remember when we learned about the laws of photochemistry, we learned about Beer-Lambert law. What we said there is that whenever a monochromatic light passes through a sample, right? So we need a monochromatic light so that the radiations so that we have an idea about the wavelength of the incident radiation. We only need monochromatic radiations to enter our sample. So what we here need is a dispersing element which will select a single wavelength from all these radiations. So that is the function of this dispersing element. How it happens, we'll discuss that later. So this is the incoming radiation from this dispersing element, and together this collimator and the dispersing element, you call it a monochromator because it gave you a monochromatic radiation. Now this incident radiation, it enters into the sample. This is called as cuvette. You have your sample inside it, so it passes through this. Then the sample, the solution here, it absorbs the radiation, some of the radiations, and emits some of the radiations. Let's say the intensity of the emitted radiations is I. So up to now what we did is, the radiations, they were collimated, then a single radiation was emitted which entered into the sample. The sample absorbed some radiation from this, and the intensity of the transmitted radiation was I. Then after this, what we need to record in the spectrophotometer, what the spectrophotometer has to do for us is, it has to tell us what the intensity of the emitted radiations is. In other words, it has to tell us about I, right? But the spectrophotometer, it records absorbance or transmittance. So, but this, it's an electromagnetic radiation, right? This thing which comes out, it's an electromagnetic radiation. And what we get on the spectrophotometer, that's a digital signal, right? We get, for example, for absorbance, we get values like 0.005, or we may get 0.05 absorbance value. What is the device that converts these electromagnetic radiations into these values, or into these digital signals, into these electrical signals? That part of the UV visible spectrophotometer is called as the detector, right? This detector thing, it does everything. It converts, what's the function of the detector? Basically, it converts the electromagnetic radiations or the light energy into electrical energy, into electrical signals. Then those electrical signals are recorded and we get the output spectrum on a, usually it's a monitor where we get our spectrum. So this is the working of a UV visible spectrophotometer. How each different component works, that we will see.